What's up, everybody? This is a lesson on how to solve a one-step equation. No matter how different these problems look today, you are still going to follow this one step. Isolate the variable, meaning you want to get the letter all by itself. You want to get rid of whatever is in the same expression. So I'll explain what an expression is in a second. The way that you're going to isolate the variable is use the inverse operation, meaning the opposite operation. If you see an addition sign, you're going to use subtraction. If you see a subtraction sign, you're going to use addition. If you see multiplication, you are going to use division. And if your variable is wrapped up in a division problem, you will use multiplication. What is an equation? An equation is an expression equal to another expression. It's like a math problem written one way and its equivalent written another way. It's almost like you're translating two languages. Think of el baño equals bathroom. The spelling is different, but they mean the same thing. They are the same place. Sorry, that's the only word I can think of right now. Okay, back in kindergarten. By the way, is it kindergarten or kindergarten? I don't know. Don't send me an email about that word. Okay, back in kindergarten, you were doing these style of problems, and you would fill in that mystery box. What number plus 5 equals 12? Well, we all know that that would be 7. And your kindergarten teacher praised you for getting the right answer. Neat, it's 7. And then you moved on, you graduated to first grade. Hooray. But in 6th or 7th grade, we give you the same exact problem. The answer is still 7, right? What number plus 5 is 12? The answer is still 7. But if you just write the answer of 7, I am not going to pass you on to the 8th grade. You were learning how to communicate how to get 7. So let's think about this. If we go back to your step on how to solve this equation, we need to isolate the variable. So looking at this expression, x plus 5, how can we make it so we just have an x here? We want to get rid of plus 5. Well, if you come back to this idea, if you see a plus sign, you're going to subtract. So in the left expression, I am going to subtract 5 from the left expression. And what you do to the left expression, you have to do to the right expression. So I'm going to subtract 5. Anytime you add or subtract in these equations, you want to draw that equal sign. I've already taught you that these are called additive inverses. Their sum is 0. So we're going to cancel those out. And we're left with x in the left expression. And 12 take away 5 is 7 in the right expression. You're learning how to communicate to that kindergartner why it's 7. Not just that the answer is 7. So I wrote a couple examples. Think about these problems. In the left expression, x, we want to get this x all by itself. If you want to circle that x to protect it, okay. And then it's quite clear what you have left in this expression. You have a plus sign and a 5. So we're going to subtract 5. What you did to the left side, you're going to do to the right side. Additive inverses cancel, and x equals 3. In the right expression, we have our variable. We want to protect it. So we have a 7 here. How can I make that a 0 or get rid of it? I'm going to subtract 7. What I did to the right expression, I have to do to the left expression. It's a lot like a teeter-totter. In order to keep it balanced, what you do to one side, you have to do to the other. Look at my left expression. I want to get C all by itself. It says minus 7. Guess what you're going to do? You're going to add 7. What you did to the left expression, I want you to do to the right expression. You do not have to cross out and you don't have to circle your variable. If I wanted that x all by itself in its own expression, I'm going to get rid of minus 2 by adding 2. What I did to the right side, I'm going to do to the left side. Okay, look at this equation. This says 3 times what number equals 21? If you see multiplication, and maybe this is the first time you're ever hearing this, but this is a multiplication problem. There's a tiny little multiplication sign that you don't get to see. It's right there. So if you see multiplication, you're going to undo multiplication by dividing, and you're going to use a fraction bar. If you want to get that x all by itself, you're going to divide both sides by the coefficient. The reason why is the coefficient divided by itself is always going to be 1. So we have 1x equals 21 divided by 3 is 7. Take a look at this problem. Same idea. It says 40 is negative 8 times what number? Well, if you say times, I'm going to divide. And I'm going to divide by the coefficient of x. What I did to one side, I have to do to the other. Any number divided by itself is always 1. So there's 1x in my right expression. 40 divided by 8 is 5. So 40 divided by negative 8 is negative 5. Last but not least, this problem reads, what number divided by 3 is 4? In this expression, I want to get x all by itself, but I said divided by 3. So you are going to multiply by 3. Take a look at the 3 on the left. It's diagonal from that 3 in this fraction. Do you recall that you are able to cross-cancel or cross-reduce? That's why those 3s, that's why I put that 3 up so high, is I'm trying to get this expression to just say my variable, x. X is 12. If I wanted to check my answer, I could just plug it in and say 12 divided by 3 is 4. That's true. Last problem. 10 is what number divided by 4? If I want that c all by itself, I want to get rid of divided by 4 by multiplying by 4. Notice that I put the 4 in a diagonal fashion. What I did to the right expression, I got to do to the left expression. Guys, all these problems are the same. You're doing the same exact idea. Isolate the variable by doing the opposite of what you see. You could almost call it opposite day problems. Okay, in under 9 minutes, I hope one-step equations was familiar to you, and this is just a quick reminder. Good luck.